Welcome all to this video lecture. I am Anu Sanni, working as Assistant Professor in AAA Department of Jyoti Engineering College, Cheruthuruthy. Today, I am going to discuss about the generation of three-phase voltage. The contents that I have included in this lecture are: first, we will see the application of three-phase AC power. Then we will discuss why we go for three-phase instead of single phase or more phases. Then we will get into the details of the generation of three-phase AC voltage and the phasor diagram of three-phase voltage. So, first we will discuss what are the areas which uses the three-phase AC voltage. The power generation, transmission and distribution of electrical power in our country is done in three-phase because it is more economical to transmit three-phase power instead of single-phase power. And almost all industries uses three-phase power, and all the motors which are used in the industries are three-phase motors. And also, if in domestic installations, if the load is greater than 5 kilowatt, then such domestic installations are supplied with three-phase power. So what is this three-phase system? In a three-phase system, there are three equal voltages or EMF of same frequency having a phase difference of 120 degrees. That is, there are three voltages having same frequency and same magnitude, but they have a phase difference of 120 degree. That is a three-phase AC system. So, now we will think what is the advantage of having three-phase system over single-phase system. There are mainly two types of systems. One is single-phase system and other is three-phase system. In single-phase system, the power is transferred through one phase and a neutral, whereas in three-phase system, the power is transferred through three phases. So what is the advantage of transmitting power in three-phase? So what are the advantages? First one is, if we consider two machines, one is a single-phase machine and other is a three-phase machine. That is, the supply we are giving to that machine is three-phase, whereas for a single-phase machine we are giving a single-phase supply. And if the frame size of both the machines are same, then we can say that the three-phase machine will give 1.5 times output than a single-phase machine. So that is an advantage. That is, for the same frame size, a three-phase machine gives nearly 1.5 times output than a single-phase machine. Now, another advantage is that in a single-phase circuit, the instantaneous power will be pulsating. That is, pulsating means it will be changing its magnitude. So in a single-phase circuit, the instantaneous power is pulsating, whereas in a polyphase circuit or in a three-phase circuit, the instantaneous power delivered will be almost constant, because even though the power in one phase is pulsating, if we take the total power in three phases, we will get a constant value. So we can say that in a three-phase system, the power delivered is almost constant. Then another advantage is that if we are transmitting same amount of power over a fixed distance at a given voltage, then a three-phase system requires less conducting material compared to single-phase system. That is, the volume of conductor material required for three-phase system is less than that of a single phase system for the same amount of power for a given distance. Now, another advantage is the three-phase induction motors are self-starting, whereas single-phase induction motors are not self-starting. So, for a single-phase induction motors, we have to provide additional equipments to start the motor, whereas in a single-phase induction, three-phase induction motor will start automatically. Now, another advantage is a three-phase alternator. A three-phase alternator means a three-phase generator is small in size and light in weight as compared to single-phase alternator. And a three-phase induction motors have high power factor and efficiency than single-phase induction motors. So these are the advantages of three-phase system over single-phase system. That is why we are using three-phase system in almost all industries and also for power generation, transmission and distribution in our country. Now, we look into the details of the generation of three-phase EMF. So, what is a three-phase EMF? A three-phase system consists of three equal voltages of same frequency and magnitude and having a phase difference of 120 degree. Now, these three voltages are generated by a three-phase generator which is called as an alternator, and this alternator will be having three identical windings which are displaced apart from each other by 120 degree electrical. So, we know that according to Faraday's law, whenever there is a rate of change of flux, an EMF is induced. So, to generate an alternating voltage, a coil is to be rotated in a magnetic field, or the coil is kept stationary and the magnetic field should be rotated. So, here in this figure, we can see that there are three coils which are displaced by 120 degree, and to generate three-phase voltage, either these coils should be rotated in a magnetic field, or the coils are stationary but the magnetic field is rotating. So we can produce three-phase voltage either by any of these two methods. And we know that in a three-phase voltage, the voltages are phase displaced by 120 degree and they have same frequency and same magnitude. So here we can see that there are three coils, A1, A2, B1, B2 and C1, C2 are the three coils. A1, B1 and C1. This is A1, this is B1 and this is C1. A1, B1, C1 are the starting ends of the coil, and A2, B2 and C2 are the finishing ends of the coil, because if we take a conductor, it will have a starting end and then finishing end. So A1, B1, C1 are the starting ends and A2, B2, C2 are the finishing ends. Now this coils are identical coils and they are rotating in a magnetic field with the same speed, and these coils are placed 120 degree apart. So if we look into the figure, we can see that this is coil A1. From this coil A1, the coil B1 is displaced by 120 degree. This is B1, and from this B1 again we take 120 degree, then we are placing coil C1. So these coils are displaced by 120 degree. So the phase difference between the coils are 120 degree. Now these coils are mounted on a same axis. They are mounted on same axis and they are rotated with a constant velocity, and they are rotating in anti-clockwise direction. They are rotating in anti-clockwise direction. So we can say that if the coils are rotated in a magnetic field, 3 EMF will be induced in the 3 coils. The EMF induced in the coil A1, A2, we can say that the EMF induced in the coil A1, A2, first it will be 0, then it goes on increasing and becomes maximum and then decreases. So this red indicates the voltage induced in coil A. It will be a sine wave. Now, what will be the voltage induced in coil B? We know that the coil B is 120 degree phase displaced. So, the voltage in coil B will start from here. That is, after 120 degree, it will start. Then it goes on increasing and then decreases, becomes 0 and then it becomes negative. So, if we extend this voltage in B to this side, this will be negative and it will be going like this. Now, if we plot the waveform of voltage induced in coil C, we can say that the coil C is again 120 degree phase displaced from B. So, this is the starting point of B. From here, we have to take again 120 degree. So, so from this origin 0, we will be now at 240 degree, and the voltage in coil C will be starting from this point. It goes on increasing and then decreases. So if we extend this voltage to this side, this will be negative and it becomes 0 at this point, and then it increases in this direction. So this is the waveform of 3 voltages. Hope you understood. Now we will draw the phasor diagram of these 3 voltages. We know that what is a phasor? A phasor is a vector which is rotating at constant angular velocity. So these 3 voltages can be represented by phasors. So we know that the voltage induced in coil A is Em sin omega t. The maximum voltage magnitude of the voltage is Em, and since it is a sine wave, we can represent it as Em sin omega t. And what will be the voltage induced in coil B? It will be Em sin omega t minus 120 degree, because the voltage induced in B lags the voltage induced in A by 120 degree. So this will be omega t minus 120, whereas the voltage induced in coil C will be Em sin omega t minus 240. So if we draw the phasor diagram, first we will draw the voltage induced in coil A. It will be like this. Then next we have to draw the voltage induced in coil B, which is 120 degree lagging. So the phasor is rotating in anti-clockwise direction. So this represents the coil B, and again we have to take 120 degree lagging, then we will get the voltage induced in coil C. So this will be the phasor diagram of 3-phase voltages. So hope the topics are clear. We discussed about the advantages of 3-phase system or a single phase system, and we discussed what are the areas or what are the industries which are using the 3-phase voltages, and we discussed about the generation of 3-phase voltage and the phasor diagram of 3-phase voltages. Hope all of you understood the topics. Thank you.